Okay, we're going on to a new section, section 5, and this deals with equations of a line. Notice the plural. Well, we've had a number of equations. Here we had standard form, slope-intercept, point slope. This one, I don't know if we're getting it later in this section or next section. And then we've had the special of horizontal line, vertical line, and these were just hints as to whether they're parallel or perpendicular. But we're going to focus in now on slope-intercept, which is Formula 2. And they want us to use slope-intercept now to graph these lines. So what's involved here? Well, there is a little protocol involved, and basically it starts off like this. And again, we're showing you strategy. The first thing you do, if it's in slope-intercept, then you're all set. You're going to plot the y-intercept, which is a -2 right there. Now, from this y-intercept, you're going to plot the slope. And again, you may have had different methods in high school, but what I'm suggesting is you plot the x term here first. Remember, this is a ratio y over x. And since it's positive, from this point I'm going to go positive. 1, 2, 3, 4, 5. That would be my run of 5. And now I'm going to do my rise of 3. 1, 2, 3. And then using my ruler, there's my graph. And it's just that simple. Plot your y-intercept, and from that point, do your run first. If it's positive, it'll be to the right. If it's negative, it'll be to the left. And then do your rise, and then you're going to click on that, and it makes a nice line. Now for example 2, note that this is in standard form. So if we want to use slope-intercept to graph, we have to solve for y, which is easy here. Y equals, just transpose the 4x. So our y-intercept is a positive 1. Now we have a -4 over 1. So I'm going to go 1 unit, run to the left, and now 4 up. And I'll just sketch it in there. And there's my slope. So you're going to find that this is a super easy way, just so long as you don't make little errors. Remember, it's rise over run. If it's negative, do the run to the left. If it's positive, do the run to the right. And then look at it on a test. You say, well, this is positive slope. Yes. This is negative slope. If you had it for some reason the other way, based on those other diagrams we had over there, then you'd have to check yourself. Now you'll get an example like this every once in a while, where they will ask you to, if they give you the y-intercept, b equals this, and they give you the slope, write the equation. Well, you're going to use this form. Y equals, what's the slope? 1/4, you have to put in the x, and your y-intercept is -3. And to graph that, just for some more practice here, y-intercept is -3, slope is 1 over 4, so my run is +4, my rise is 1, and there's my graph. Okay, we are finally getting to formula number 4 here, which is the point slope form. So if we know one point and we know the slope, we can eventually put it into, they want us to put it into slope-intercept and standard form. So let's go through that. So basically it's just substitution first. Y minus 5 equals m, which is -2, times x minus, now here's kind of tricky because it's a -1. So here, minus a -1 will make this a +1. So that's the little tricky part. You got to be careful about that. So we clear the parentheses. Y equals, well, let's not get too far ahead here. Y equals -5 equals -2x minus 2. Negative, just distribute that. Get rid of that parentheses. Now we bring this term over, and we get y equals -2x, and this then becomes a +5, so that'll be a +3. Now there's our slope-intercept form, but they said they also want it in standard form. So for standard form, I have to take this, bring it over. It becomes 2x plus y equals 3. And there's our standard form, slope-intercept. Now for example 5, they don't give us the slope, but they give us 2 points. So here we have to use formula 3 first, which is what I've done, and then we'll use formula 4. Now you might say, well, which set do you want to use? Doesn't make any difference. If one has a 0 in it, it's a little easier to calculate. So we're going to go y minus 5 equals our slope of 1/5 times x minus 2. Now again, I have to choose the same ones. I could have chose those. The answer comes out the same. Get rid of parentheses. And now, a good technique, whether you're going to solve for the x, or I should say, in slope-intercept form or standard form, is to, at this stage, get rid of the fractions. And we get rid of the fractions from chapter 2 by multiplying every term by its common denominator, which is 5. So now this becomes 5y minus 25 equals, here the 5's cancel out, I get x, 5's cancel out, minus 2. So if you had to bring that 5 over here, then it gets kind of messy dealing with that fraction. So we're now going to transpose the 25, and we get 5y equals x. This comes over as a positive 25, so plus 23. Now, if I want to solve for the slope-intercept form, I can use this equation very easily. I'm just going to divide everything by 5. So y equals 1/5 x plus 23 fifths. And if I want to put it in standard form, I just take this term, move it over there, and I get a negative x plus 5y equals 23. Now this is a good case where sometimes in some books they didn't want the first term x in standard form to be negative. So what do? Well, the answer is just change all the signs. this will become then a positive x minus 5y equals a negative 23. Just change the signs. And that should do it. On these, I've cut down the wording a lot. Basically, they want you to find a line, the equation of a line that's vertical and passes through this point. Well, one thing you might do is graph it. So we have a -1, and it's going to be vertical and goes through that point. Well, what's the equation of that line? Well, remember, any vertical equation has the form x equals a. In this ordered pair, what is a? Well, a is -1. So this equation is x equals -1. You could have picked it up from the graph or from the ordered pair using this criteria. Got a vertical line, the equation is number 6, x equals a. And what's in the a position of -1? And in 7, we could do something similar. We want a line that is parallel to y equals 5. What kind of line is that? That's horizontal. So what equation is horizontal? Well, equation 5. Y equals b. What's in the b position here? -3. So the answer to this one is y equals -3. That would be a line that is parallel to y equals 5, and all horizontal lines are parallel. This is the formula for parallel lines, and they wanted to go through this point, so we're looking for your b element there. Again, a lot of good stuff, but again, you'll have to study, practice. This one's a little wordy and takes a little while, so to shorten it, I've summarized it. We want to predict the sales of t-shirts. Now, they tell us that if the price of the t-shirts are $6, they expect to sell 2,000. But if the price went up to $8, they expect to sell 1,500. So can you see this is a set of data here? How many could they expect to sell if the price was $7.50? That's our big thing. So what do we need to do? Well, we need to, and they're assuming that this is linear. That is, it's a straight line. So we put our data into our slope formula. 2,000 minus this, 6 minus this, gives us a slope of a negative 250. We put that into formula 4, and I'm using the first set of data, grind it through, and we end up with, and you can pause it if you want to see it, or the work is all in your textbook as well, that you would expect to sell 1,625 t-shirts may be sold if the price is $7.50. So again, this is declining slope here. So that means the cheaper the price, the more you will sell. The greater the price, the fewer you will sell. So in a graph, it's going to be something going high on the left, going down to the right. They didn't ask us to graph that, but basically that's it. Okay, that winds up section 3.5. I think there's only one more section to do.